Okay, so percent composition is the third topic in the series, and we're going to go back to our friend here, lead 4 nitrate. And if we look at that again, we know that we've got one lead. We can do that again here. We'll write that down. So we got one lead atom, nitrogen. We've got 1 times 4. So we got 4 oxygen. We got 3 times 4. So we got 12 atoms. So we know there's 17 atoms in that molecule in this compound because it's ionic. We generally don't call it a molecule. So we can refer to it as either the compound mass or the formula. And then we did the mass. So this was 207.2, I believe. This was, times 14, 56, 12 times 16. And I think we said that was 196. And then we added that up, 13, 9, 16 and 9. Did I do that right? 2, 13, and 6, 19 carry the 1, so 1. Yes, okay. And then we said that was AME. So if you watched the last video, that's just a repeat of that. So now I ask the question, looking at this compound, if we didn't know this, and I asked you, well, what percentage of this formula is lead, what percentage is nitrogen, and what percentage is oxygen? Or re-ask the question, which atom makes up most of this molecule, or most of this compound? You probably would have said oxygen because we got 12 oxygens. So if you look at a picture of this compound, we're certainly going to see more atoms of oxygen. But as a chemist, we care about mass. I mean, that's why we did this. We want to know the mass. So from a mass percentage, the question is not how many atoms, but what mass, what percent of each, or what percent of the total does each of these atoms represent? And to find that is exactly like you would have normally found a percentage on a test. So again, if you found, or you got a test back and you got 15 out of 20, you know that that's 75%. Yes, Trinity?
Your oxygen number is wrong. It's like 12 times 16 is 192.
Oh, 92, thank you.
Yeah, so the bottom number should be 1255.2.
Thank you.
My numbers went out now, so I was
No, I appreciate it. I went really quick. Like I said, I just kind of tried to remember what the last video was. Okay, so if you got 15 out of 20 on a test, well, you know that that's 75%. Obviously, if you got 20 out of 20, that would be 100%. So when you do percentages, you're thinking about the part out of the whole. And that's always what we're kind of thinking of. So what if we wanted to find the percent of lead? What percentage of this compound is lead by mass? So this is the part, this is the whole. So the percent lead is just 207.2 divided by 455.2 times 100. So let's go ahead and do that calculation. So 207.2 divided by 455.2 times 100, and I get 45.5%. So that tells me that in 1 unit of this compound, 45.5% of the mass comes from the lead. And let's do the oxygen. So percent, well, actually we'll do these in order. So percent nitrogen. So now I'm doing this part over the whole. So 56 divided by 455.2, and I get 12.3%. So 45.5% lead, 12.3% nitrogen. And then finally, percent oxygen. Before I do that though, do I even need to do the math for oxygen? What have I got so far? 45.5 and 12.3. Add and subtract, right? Subtract from what? 100, because by definition, percent is literally means out of 100. Cent is Latin for 100. Think about centi, 100. Centennial, 100, right? So I know that if I add these two together, I'll get 57.8. And if I subtract that from 100, that's 42.2. I think I did that mental math right. You can double check on that. But we're still going to do the math because I want to make sure. But if you understand percentages, you know that all the parts have to add up to the whole. Otherwise, it doesn't make sense. So our total mass of oxygen is 192. Total mass all together, 455.2 times 100. And if I plug that into my calculator, I get 42.2 when I round. So that is in fact, and then that's always a good check, right? Because now if I look at this, those three have to add to 100%. Okay. Can you think of a practical application where a chemist would want to know what percentage that particular atom comes out of a compound? Remember I said that what drives the world, it's the economy. We want to make money. So as a chemist, you're trying to make money for whoever, maybe for yourself or the company you're working for.
Yeah.
Yes, because definitely we want to know if we're trying to make a specific product or refine a specific metal. And if you think back from that, where do metals come from? For the most part, mines. They come from the ground. And with relatively rare exceptions like gold and silver and copper, the metals that come from the ground are combined with other elements like sulfur or oxygen. That's what ore is. Ore is never really a pure substance. It's a mix of stuff. And then, so we talked about those mines in Africa, trying to mine things like coal tar, which is a mineral that gives, oh crap, I can't remember the, it's one of the rare earth metals that we use for phones. I think it's, coal can. I'd have to do a quick search, but then a chemist has to come in. So all of that rock that's collected, they have to pulverize it into small amounts, and then they have to react it, usually with harsh chemicals, to release the metal ions, and then collect those metal ions and have them precipitate out so that you get pure metal out of that. It's a very, very intensive process. And again, a lot of times it's very destructive, not just to the local inhabitants in terms of their health, but also pollution of the waters, destruction of ecosystems and habitats. In some ways, you could be killing off natural habitation, destroying species. So it's a pretty invasive process. If you've ever seen strip mining or open pit mining, it's not pretty. There's nothing about mining that's pretty. Okay, so that's where this kind of comes into play, because you want to know how much metal you can release from that ore. All right, so I'm going to stop the video there. You're going to practice on the worksheet.